Welcome to the bite-sized webinar, DPI-Driven Network Visibility, Open Source versus Commercial. I'm Ariana Lin, Principal Analyst and Senior Editor at the FastMod. With me today, I have Daniel Findyson, Application Engineer at ipoque, a subsidiary of the Rohde Schwarz company and a leading vendor of next-gen DPI software. We will begin our session today with a quick overview on network visibility and deep packet inspection. In particular, we will explore open source DPI and its technical capabilities, benefits, deployment advantages, costs, security gaps, and more. We will then look into how this compares with commercial DPI, some of the factors pushing vendors to shift from open source DPI to commercial DPI, as well as the impact of a migration tool. Following this is a session by Daniel where he will focus on commercial DPI technology. Daniel will explore ipoque's cutting-edge next-gen DPI engine, RNS Phase 2, and its performance, service, support, and key components, including encrypted traffic intelligence. If you have any questions during the session, please type them into the live chat box, which should be on your right. We will get back to you during the session or after via your email. Okay, so the findings presented in this webinar are based on the recently published research report titled State of Open-Source DPI, Challenges, Opportunities, and Alternatives. The report, which was released last month, is jointly produced by ipoque, a Rohde Schwarz company, and the FastMod. It is based on a survey of 48 leading networking and cybersecurity vendors, and that took place from March to April this year. To read the report, please visit bit.ly/open source DPI report. Okay, so let's start. What is visibility and what is its role in the network? Visibility, whether it's deployed at the end user's device, at the network edge, at the core, in the data center or in the cloud, provides insights and intelligence into the transactions taking place on the network in real time. It looks at who is making a request, where is the request coming from, where is it going, what is the underlying application, what is its speed, is there any latency, is the traffic suspicious, and so on. All this data forms the basis of network visibility, which is crucial in supporting key network functions and use cases, including security, network performance and service assurance, analytics, traffic management, and policy control. For example, with fine-grained visibility, security devices such as next-gen firewalls and intrusion prevention systems can instantly detect malicious or anomalous traffic and block them. Okay, so there are many technologies that provide network visibility, such as network packet brokers, flow analysis tools, and network performance monitoring solutions. In this webinar, however, we will be focusing on one popular visibility technology, which is deep packet inspection, also known as DPI. Okay, so, what is DPI? DPI is a form of network filtering, network packet filtering, that examines the data part as well as the headers of an IP packet as it passes an inspection point. This advanced method of network traffic analysis provides a more detailed understanding of IP flows compared to traditional methods. In contrast to shallow packet inspection, DPI goes beyond just looking at basic header information and analyzes packet payloads in real time to gather granular insights into network traffic. But that's not all. DPI also uses inter-packet patterns and behavior to detect the underlying application or service type of a flow by, for example, recognizing patterns in how packets are structured, their size, and the timing of their delivery. In fact, most modern DPI engines do not even have to read the payload, especially in the case of encrypted traffic, where it is impossible to do so, because these DPI engines leverage advanced statistical, behavioral, and AI-based techniques. We will explore these techniques in detail later. Okay, so DPI is typically used to monitor, filter, block, reroute, log, and take other actions on IP traffic in real time. It can be deployed as a standalone function or more commonly as part of a larger networking or cybersecurity tool. There are few types of DPI that exist today. In this webinar, we are going to zoom in specifically on open source DPI. As DPI is entirely software-based, there are several DPI tools whose source code is publicly available for anyone to download, modify, and deploy. These open source DPI tools are developed and updated in a public and collaborative approach and administered by a single maintaining organization. They are free to use and can be instantly deployed. Okay, so this is in contrast to commercial DPI solutions, which are developed and maintained by a third-party company with experienced engineers and researchers. Commercial DPI solutions typically go through much more rigorous testing and quality control and come with guaranteed SLAs and round-the-clock service and support. They are often licensed on a subscription basis. And lastly, we have in-house DPI, which is DPI that is custom-built by the organization itself for its own use case. Okay, so according to the report, 100% of the survey respondents are familiar with open source DPI, as these respondents were selected from current and past users of open source DPI. Of these, 89.6% and 78.7% are also familiar with commercial and in-house DPI respectively. Okay, so DPI has two core functionalities, which is classification and metadata extraction. Classification aims to label packets or flows and organize them by predefined categories, such as protocols, applications, application types, application service types, and so on. Metadata extraction obtains additional information about these packets, such as performance metrics or QoS metrics. Okay, so we first look at the classification capabilities of open source DPI. We start with the most basic form of classification, which is by protocol. This includes protocols at layer 3, layer 4, and layers 5 to 7. According to the report, 76.3% of respondents said that open source DPI can comprehensively classify traffic by protocol, while the remaining 21.7% said that it can do so moderately. Okay, so now that we have identified the protocol, up next is the application. Examples of applications include Facebook, Google, Zoom, or Salesforce. Unlike in the case of protocols, only 28.3% of respondents said that open source DPI could classify applications comprehensively. The bulk say that it can do so moderately, while a fifth say that it is limited in its ability to do so. Likewise, for application service types, only 28.3% of vendors agree that open source DPI can deliver comprehensive classification. Examples of application service types includes video, audio, file transfer, or voice message. Service type information adds on to application awareness, providing fine-grained insights. For example, it can determine if a Facebook packet is a text message or if it's a video call. Daniel will later explore commercial DPI's traffic classification capabilities in more detail. Okay, so aside from protocols and applications, IP traffic can also be classified by whether it may be a cyber threat or if it appears to be anomalous or suspicious. Cyber threats include attempted attacks such as spear phishing, distributed denial of service, code injections, malware, or ransomware. Anomalous traffic, in the meantime, refers to traffic that is not clearly a threat but that displays suspicious behavior, such as large file downloads or repetitive requests. This report finds that 15.9% and 15.6% of respondents agree that open source DPI can comprehensively classify cyber threats and anomalous traffic, respectively. Another 40.9% and 40% say that it can do so moderately, while 38.6% and 37.8% say that it can do so limitedly. 4.5% and 6.5% of vendors, respectively, admit that open source DPI fails to classify cyber threats and anomalous traffic. Okay, so now that we've seen the classification capabilities of open source DPI, what about the techniques it uses to perform this classification? The most used technique is pattern matching, which basically matches IP packet information against a database of known patterns. 59.1% of respondents say that open source DPI uses this technique widely, while 36.4% say that it is used moderately. Second is statistical analysis, which is the analysis of large available data sets using statistical inferencing and probability distributions. And third is behavioral and heuristic analysis, which observes session flow and packet transmission patterns and user interactions. These techniques are used significantly, according to 27.9% and 14.3% of respondents respectively. Advanced caching techniques are less used, with only 7% of respondents saying that they are used significantly. Caching in this case relies on past results stored close to traffic filtering points and includes service and DNS caching. The least used method is machine learning and deep learning. Machine learning uses known traffic attributes to develop identification algorithms from large data sets, while deep learning uses neural networks to extract these attributes automatically. Only 2.4% of respondents say that this method is used significantly. A vast majority find it being used minimally, and a quarter of respondents say that it is not used at all. Okay, so these techniques mentioned above leverage extensive signature libraries containing thousands of predefined patterns. As new applications and threats emerge, however, these patterns have to be updated to reflect the latest changes. When asked if the signature libraries provided by open-source DPI are updated frequently enough, 52.3% said that they were not updated frequently enough. Okay, so classification is the first core functionality of DPI. The second is metadata extraction, which, as we explained earlier, provides additional information on a packet or a flow beyond classification information. Examples include host and destination URLs, performance indicators such as speed, latency, or jitter, or user information such as location and device types. When asked if the traffic metadata provided by open-source DPI is sufficient to support common DPI use cases, 20.5% of the respondents strongly agree that it is sufficient, while 34.1% moderately agree, 40.9% somewhat agree, and 4.5% disagree. Okay, so now moving on, what about encryption? By encrypting IP packet payloads, visibility into network traffic is compromised, and this significantly impacts DPI's ability to classify applications. The report explored this, assessing which encryption protocols are best supported by open-source DPI. TLS, including TLS 1.3, which is one of the most commonly used protocols on the web today, was found to be the protocol that was most supported, with 73.3% of respondents agreeing that open-source DPI can classify traffic encrypted with it. This is closely followed by QIC and other Layer 7 protocols, as well as VPN protocols. Understandably, TLS extensions such as SNI and ECH are less supported, with only 56.8% of respondents stating that open-source DPI can detect traffic using these protocols. This figure is similar for DOX protocols such as DNS over HTTPS and DNS over TLS. Both TLS extensions and DOX hide more than just packet payloads, which is why open-source DPI may struggle with them, especially since its use of machine learning and deep learning is still in its infancy. As for visibility into anonymized traffic, which is traffic that masks user identities via the use of VPNs or CDNs, 50% of respondents say that open-source DPI is capable of detecting such flows. The number is slightly lower for obfuscated traffic, which is traffic that is intentionally disguised via methods such as domain fronting and tunneling. Okay, so we have here various benefits of open-source DPI. Top of the list is vendor neutrality, with 62.5% of vendors strongly agreeing to this being an advantage of open-source DPI. Low initial costs from not having an upfront licensing fee follows next, with more than half of vendors strongly agreeing to this. Also, open-source DPI enables faster deployments as codes are instantly accessible and usable. A third of vendors strongly agree to this. There are various other merits to open-source DPI, as strongly agreed to by 31.1% of vendors. Open-source DPI often boasts a thriving community of users who assist and share resources among each other. Open-source DPI's form factor is also a boon for users. 27.1% of vendors strongly agree to this being an advantage, as it allows easy embedding in any end solution or appliance. Lastly, 22.9% of vendors strongly agree that open-source DPI also provides a lightweight implementation. While open-source DPI comes with some significant advantages from being vendor neutral and license-free, there are other aspects, namely in terms of deployment, where it displays a number of shortcomings. As a component that is built into a wider solution, ease of integration often weighs heavily in DPI deployment decisions. In this aspect, open source is rated excellent by 34.8% of vendors. However, almost a quarter say that it is limited or poor in this aspect. API and API stability is another area of assessment, and here 26.1% of vendors say that open source DPI is excellent. Again, close to a quarter say that it is limited or poor. Similar ratings are accorded to open source DPI's continuity in the long run. Open source DPI also has a relatively poor global presence, with more than half of vendors rating this aspect as limited or poor. What's more important though is the level of support and customer service offered by open source DPI. This is an important contributor in its deployment success, as well as in ensuring no disruptions or downtime to the end service. Open source DPI's limitation is quite obvious in this area. The survey finds close to 3/4 of respondents saying that open source DPI has limited or poor customer service. Okay, so the report also assessed the cost implication of open source DPI. Open source DPI, as we know, incurs zero licensing fee, which translates into a very low initial outlay for vendors. However, if we look at all the costs incurred throughout the lifetime of its deployment, we see a different story. Okay, so let's take an example of the losses from issue resolution delays. Due to a lack of immediate and comprehensive support, vendors tend to experience lags in how fast they fix issues, which inevitably leads to increased downtime and subsequently monetary losses. 50% of respondents report these losses to be very high or high. Customization costs are another aspect that needs to be considered when selecting open source DPI. We find that 46.8% of vendors reporting very high or high customization costs, as any tweaks to the software require a mix of expertise in DPI and the solution vertical. Other cost implications for open source DPI come from operational costs and also upgrade costs, although these are much less critical. Okay, moving on. One of the glaring insights from the survey is the impact of open source DPI on security. As most of us would anticipate, the respondents voiced a number of key concerns, namely the loopholes that are created during internal customizations and the inherent bugs or errors in the software. The number of respondents that find these two concerns to be a major issue or quite an issue are 53.3% for both areas. These are followed by the vulnerabilities that crop up from the adoption of unverified or untested open source DPI versions, the prevalence of which can be attributed to the fact that most deployments are not adequately validated or by qualified experts or the maintaining organization. Adding on to these concerns is of course loopholes that arise during integration, as different solution architectures necessitate different considerations. Surprisingly, we find that open source codes being accessible to anyone is not that big of an issue as anticipated. Only 23.9% of vendors see this as a major issue or quite an issue. Okay, so via the survey, we wanted to explore open source DPI's users' take on commercial DPI and their motivations to upgrade to a commercial DPI solution. The shift is, of course, a natural progression that comes with the evolution of vendors' needs over time in terms of DPI's capacity and capabilities. As expected, the growth in traffic volumes emerges as the biggest push factor, with 62.2% of vendors agreeing to this, followed by the need for powerful libraries and the concerns that arise from increasingly complex traffic types, both of which recorded a 57.8% share of respondents. Arguably, new applications, distributed cloud architectures, emerging protocols, and so on have all made traffic analysis a lot more complex in recent years. Okay, so looking at other factors, as organizations grow and scale up, customer care inevitably becomes more crucial. We have 53.3% of vendors citing this as a push factor. Likewise, the need to address traffic that is encrypted, obfuscated, or anonymized also calls for superior DPI techniques. Vendors also expect commercial DPI to offer better security and to be more cost-effective in the long term. We have here 44.4% and 42.2% of vendors citing this respectively. Okay, so the remaining factors that influence vendors' move towards commercial DPI based on the survey are the increasingly complex customization requirements and the need for well-defined SLAs. Okay, so while we recognize the need among vendors to progress towards DPI solutions that offer lightweight implementation and unlimited processing capacity and advanced capabilities such as encrypted traffic intelligence, cloud processing speeds, and integration with default reporting systems such as ipoque, many vendors are continuously held back by migration capabilities. Reconfigurations can be time-consuming and very complex, especially in cases where DPI feeds are linked to multiple components in the end solution. The survey analyzed the role of a migration tool in influencing vendors' decisions and found that 82.2% of vendors agreeing that it can impact their upgrade decision. A migration tool allows vendors to export their current configurations in their open source implementations to a commercial DPI solution that offers such a tool. It allows the information structures, custom signatures and thresholds, as well as algorithms and databases and files to be reused, speeding up integration and deployment. This is a great insight for both the DPI providers and vendors as it spurs take-up and also facilitates upgrades. Already, 36.2% of the vendors surveyed are in the midst of moving to a commercial DPI solution, so having a tool will benefit this category of vendors and will certainly be a huge enabler for others thinking of making the switch. Okay, so I am now handing the session over to Daniel, who will explore commercial DPI technology in detail, specifically ipoque's next-gen DPI technology. Over to you, Daniel.
Thank you, Ariana, and welcome to today's webinar. As mentioned earlier, I'm Daniel Findeisen, Application Engineer at ipoque, a Rohde Schwarz company. I'm excited to be here today and to be able to discuss the advantage of commercial DPI with you. But before diving into details, let me first give you a short introduction to ipoque. ipoque was founded as a software startup in Leipzig back in 2005 and was acquired by the Munich-based electronics group Rohde Schwarz in 2011. Currently, ipoque has over 300 employees and a very strong focus on R&D. We are the leading provider of advanced future-proof IP analytics software that delivers real-time visibility of IP network traffic. Our next-gen DPI engines are embedded into telco, network, and cybersecurity solutions, which enables reliable application classification. ipoque develops software solutions that empower our customers to understand the network data and help transform raw IP data into the network insights needed to analyze, optimize, and manage networks efficiently and to ensure the highest connectivity and security. So let us learn more about next-gen DPI. Our DPI engines, Rohde & Schwarz, vPace, and Pace2, are easy to integrate and simple to manage OEM software libraries that are shipped with extensive user documentation and implementation examples. It's widely used by network analytics, network management, and cybersecurity vendors. Our technology is used by the world's top 4G and 5G telco, networking, and cybersecurity companies such as Microsoft, Cisco, Exfo, Ographiant, and many more. Next, let us dive into the typical detection stack of one example flow. We define a flow or a connection as a 5-tuple. In this case, it's a WhatsApp 5-tuple connection. Our engines detect according to the OC model, meaning layer 3 to layer 7. Furthermore, we introduced an over-the-top application layer. We call it the virtual layer 8. In our example, WhatsApp can be transferred via the layer 7 protocols HTTP, TLS or HTTPS, RTP, and STUN. On top of the application layer, we can further detect service types. For WhatsApp, these can be video, audio, chat, or file transfer. On top of the protocol and application classifiers, Pace2 and vPace support additional metadata extractors such as bandwidth usage, traffic volume, encryption details, or attachment types, as well as quality of service, quality of experience indicators, such as jitter, throughput, or packet loss. Both engines are designed for encrypted traffic intelligence. We'll discuss this with the next slide. Additionally, we support many other features and extensions via plugins, like custom service classifiers for user-maintained signatures in JSON files, tethering detection for hotspot scenarios, or mobile user equipment. Furthermore, we provide different types of first packet classifications, which we will also discuss on the next slide. Let us now discuss the encrypted traffic challenge. Nowadays, over 95% of traffic is either encrypted by TLS or QUIC protocol. Nevertheless, even in cases of upcoming fully encrypted handshakes like encrypted server name identifications or encrypted DNS messages, we can provide visibility with supervised machine learning approaches like KNN and decision tree models. In combination with our caching methods, we achieve highest classification coverage on nowadays encrypted traffic. Our first packet classification methods are enhanced by a service caching method that caches already detected services and via an IP address database covering huge IPv4 and IPv6 address ranges. As shown in the previous slide, we use machine learning, deep learning, and high-dimensional data analysis for encrypted traffic visibility and application detection. With these techniques, we are able to identify encrypted, anonymized, and obfuscated traffic. To make this possible, we use over 1,000 of machine learning features, including statistical, time series, and packet-level features. Summarizing other unique benefits of our commercial DPI engines, we offer high performance in terms of throughput per physical CPU core. Depending on the traffic profiles, we reach up to 20 gigabits per second. Additionally, our memory footprint is highly optimized to also be suitable for small and embedded hardware, allowing for easy integration into customer premise equipment on MIPS or on ARM v8 platforms. Our weekly update cycle combined with dynamic update APIs allow for stable APIs internally and are upgradable on a weekly basis for up to 3 years with no need for recompiling or relinking. The weekly signature updates include new applications and protocols, updates for existing applications, as well as maintenance. So, what are your benefits licensing DPI from Rohde Schwarz? You accelerate your time to market and get up-to-date applications and protocols even without any downtime. You can be sure of our rigorous quality assurance processes and get on-site application engineering and performance optimization consulting and ongoing support before, during, and after deployment. We provide flexible SLAs that fit your needs and lets you influence the DPI roadmap. And when migrating from an open source to our DPI engine, you will receive migration assistance. Thanks again for joining me. My name is Daniel Findeisen. For more information, please check out our blog post, white papers, and case studies at ipoque.com. Goodbye. Back to you, Ariana.
Thank you for the great presentation, Daniel, and thank you to everyone watching. We hope you found this session insightful. If you'd like to learn more about this topic, you can check out the research report at bit.ly/open-source DPI report. It includes all the findings mentioned in this webinar and much more, including open source DPI's classification accuracy, its technical performance, add-on features, and its support for customization. And please email any questions you might have to ariana.lane@thefastmode.com, and we will get back to you as soon as possible. Have a good day and see you again.